we'll get started. We are now recording.
Ready to rock?
Ready to rock and roll.
Well, good afternoon.
Let me introduce our speakers. This is our lunchtime seminar. Short talks designed to entertain you for 10 minutes each. Give you a chance to eat some lunch. Our in-person guests have their food. If you're at home or in the office, hopefully you've got a bite to eat as well. And hopefully learn something interesting for you. So our first speaker is David Flynn from the School of Art, and he will be talking about creativity. David, thank you.
Thank you. And thank you all for coming. And thank you, Dr. Quinn, for inviting me back. I really enjoy it here at the Williams Honors College. So my talk today is rediscovering your creativity. I firmly believe that all of us are born wildly creative. We just kind of forget about it or we block it out. I think it's vital that we rediscover that regardless of our major. That's going to be the defining thing, I think, in our careers. Do we know our craft? Yes. Can we be creative with the application of that craft? That's a must. So what I'm finding, based on all the research that I'm doing, and it's kind of a passion of mine, oftentimes our creativity is just blocked. It's blocked by things that we've added to the pipeline over our lifetime, and creativity just can't get through. So over the next 10 minutes, we're going to talk about 5 of those things. Busy, playing it safe, panic, distractions, and we're just not having fun. It's my opinion that busy is bad, but I think all of us kind of wear it as a badge of courage. Oftentimes, we say, we're slammed, we're overextended, I have too much on my plate. But it's maybe because we're Americans. Maybe that's kind of in our DNA. If we're not busy, we're not being productive. And that's the farthest thing to be true. We stay up late, we sleep late, we arrive late. Or pulling all night. Just-in-time approach is just and not doing anything more than that. After innovation, you kind of leave that in to get by, and that's sad. My challenge to you in this first unclog is to track your time. I want you to see if you're really swamped or if you're just swamped up here. It's too big. If you've made things so big in your head you can't move. Maybe you're not allocating your time in the most efficient way. The next thing I think that we fall prey to is one-way thinking. Well, we have something that's due, and we're acting on the expectations that we think our client or our professor has, so we go that way. We get tunnel vision. You've heard it called our system, or maybe our process. To me, that's just a safe place that usually generates plain vanilla ideas that don't really rock the boat. And we need to rock the boat if we're going to do well at professionally and personally and I don't know, as a country. Creativity, to me, is innovative problem solving and idea generation. And it's based on experiencing something new. So if we're in a rut that we call a process, it's still a rut. We're not seeing anything new. We follow the same paths, we do the things we've always done. That's a perfect way to get the same ideas we've always gotten. Yes, sir.
You can speak that way, and people will be able to see you.
Okay.
There you go.
What happens in that case is we start doing the same old ideas, but we try to add a twist and we try to shine up something average. In graphic design, we say, oh, just put a drop shadow on it. That'll be cool. But it's not, right? It's not a good idea. It's just trying to polish something average. What I want you to try and do is I want you to walk to your next class. I want you to keep your phone in your pocket and look, listen, and smell your surroundings. It sounds weird, but it's really not. Walk like you've never walked there before, and you'll be amazed at what you're missing. So the challenge here is to look up, pay attention. Inspiration is all around us to spark these ideas. We busy our way past the best parts. Panic. We all do this. When's it due? How much time do I have? 11:59, right? Professors do that. This is due at 11:59. So ponder this. If you were coming up with an amazing idea, would you show up in the system that you've created for this? This is really important. Your system is important. So we're constantly up against it, right? What time is it due? So we grind and we cram and we pound out the work just to get it done. And we say things like, it'll be fine. But honestly, fine isn't good enough, right? It's not good enough personally. It's not good enough professionally. I don't want to get by. That's why I'm looking into this. This approach first forces you to grab that first idea, which is based on old information, and then you polish it up and submit it. This method compresses seriously what we have as wonderful opportunities in our assignments. And it just makes them a frustrating task. So you're checking boxes to make sure you get the requirements, to get it in, to get the grade you want. There's so much more. There's so much more to this, guys. So the challenge here, make the time to take a risk. Creativity is something that, really, it's something that might not work. We're depending on things that are assured when we need to look at things that aren't. That's where you discover. So make time to take a risk. And then rinse and repeat. If it fails, awesome. Good information, right? Failure is data that you can use to move forward. We all know this, right? Netflix, let's see, over here, look at me. Hey, something shiny. Anything that we can do to distract us, we do. We're the most connected flock of humans in history, but we're the most disconnected at the same time. The challenge here is to consider a tech detox for a week. I know it seems terrible. Think about your phone, your TV, your internet. Other than things that are absolutely necessary for school, can you survive? If you can't do it for a week, do it for a day. If you can't do it for a day, try it for an hour. Just try, all right? Here's why. Creativity is new thinking. It's approaching problems in a unique way. They all require space for them to emerge. If it's all noise, if it's all texting and gaming and whatever that is, you're not allowing any space to process any of this for an idea to emerge in. We're constantly either verbalizing or typing. So I want you to grab a sketchbook and rediscover writing and sketching. I brought some swag today for the people that are here. There's something about pencil and paper and scribbling that's beautiful. You need to embrace that. Something non-pixel related. And please don't worry about perfect. That's my challenge. I have students that come to class and they start to draw with a pencil that has a point so fine, it's like a hair. And it makes a line, and they are so focused on being perfect. Perfect is bad, and it's an illusion. Just be intuitive. Grab that pencil and make a mess. That gives birth to ideas. Last but not least, we're not having fun anymore. Fun, purely intuitive action is vital to the creative process. Absolutely vital. Nothing happens without play. So we've kind of drummed that out of the core because it's not trackable, it's not manageable, and it's not gradable. Okay? Remember back before everything was so important? When you were coloring or doing whatever when you were a kid, we've covered that up with process. Totally messing something up was normal, and you didn't think twice. You just kept moving. You knock the sandcastle down and build a new one. With your vision unclouded by wondering what the professor or my clients want, you do things your way. And it's fun. It's really fun. I know this in my professional life and in my teaching. The system that we learn is efficient, and the craft is so necessary. Please don't take this wrong. We need craft, we need skill set, we need all the stuff that we're studying. But that's, in my opinion, number two. Number one is, what's the idea? What's the wonder? What's the awesome? Then you can produce that, all the craft and all the precision that you have at your fingertips. Creativity is rediscovering your natural vision and then giving it life, using the skills and craft that you learn here. So my challenge to you today is to play. Find a minute, turn everything off around you, dance like nobody's watching. It matters. It really matters. I'm not just an old guy trying to tell you things here. This is real. And it's about you. Okay? Creativity really, really is about you. But we need all of you. The OG you, right? The unaltered first generation you. Once you uncover that, that pure, wonderful, unspoiled coolness of your vision can emerge and it can come out. So don't worry about software or process or anything. Just worry about how do you see it. Once you get there, everything changes. You're executing things that you're passionate about and you believe in with wonderful technology. So my encouragement to you today is to bring your vision to your major. Don't make your major your vision, okay? Find your way back to that wonderful creativity that you've covered up. It's a good place to restart. So I want to thank you. I want to thank Dr. Quinn again and the Women's Honors College and all of my colleagues at Meyer School of Art. Come see us. We'd love to have you. I have beautiful stuff in the gallery right now. It's a good place to start getting some new ideas. Thanks.
Thank you. So if you're online and you have a question or comment, feel free to, I guess at this point you just kind of unmute yourself and let us know what you think. Or if you want to type your question in the chat, I'll read it out to David. But you know, while we're waiting, so what are, I guess from a personal standpoint, right? How often do you do this? Right? I mean, do you very often take a break, and then from internet and phone and all these other things, and then what happens when you come back?
So what I did when I started kind of running this down and trying to sort it out, don't laugh. I have a studio at home. I teach full time. I'm that busy guy, but I finally started taking a nap. Don't laugh. But I mean, 20 minutes a day, if you can separate yourself and actually unplug, it matters. I also started to read. If you want to write, you have to read. If you want to do great art, you have to look at great art. Not digitally, you have to see it in person. You have to experience it. So I try to base my research personally on anything that didn't involve pixels. And I got better immediately. So it's kind of a mindset thing. But I found it to be very rewarding and long-lasting. So I'll continue.
Okay. Well, thanks again.
Thank you. Thanks for having me. Should I just pop out the?
Yeah, just swap that out, and we'll bring up our next speaker.
The dongle is here.
Okay. So. As we make this technology switch, I'll remind you that we try to do this twice a month. So usually the first Thursday, the third Thursday, we try to bring people in for these short lunchtime seminars. So we have 2 more in November. We also have some longer seminars, and please look out for announcements and invitations for those. We always try to do things both in person and virtually to give you sort of the maximum flexibility for how you take this in. Rich, you ready?
I think I'm ready.
Did you get the?
I'm just going to.
Okay. Let's make sure everything looks okay back here. Absolutely. See a big fat cat.
Yeah.
Looks like my cat at home. So our second talk today will be given by Professor Rich Londraville from the Department of Biology, and he'll be talking about ways that we can deal with weight gain, or at least the biology of it.
Yeah.
So he told me it was okay.
So thanks very much. Thanks, Alex, for coming. Thanks for everybody joining online. It's one of my favorite things to talk about, so thanks for the opportunity. And just a general thanks to all my collaborators, students that are in the lab right now, graduate students, present and past, and funding agencies that support this work. So I'm willing to bet that anybody who's listening to this has weighed yourself within the last week and a half. That's because that's a thing that we monitor, and it's also a societal pressure in that we are thinking about what we look like and how much we weigh, maybe more than we should. So why is that? So this is the year I got my PhD. This is a map created by the Centers for Disease Control, and they ask people to self-report their weight and their height, and from that they compute body mass index, and then they say how many people in your state are of a given body mass index. And you can see in 1994 that the heaviest states in our country had less than 20% of their residents that were considered obese. We skipped to last year. They had to come up with a new color scheme because they never anticipated that we would be in this position. So now those heaviest states are less than 40% of the residents are considered obese. There are 16 of those states, and Ohio joined the heaviest 16 just this last year. We weren't before that. Not only that, but all the states in the country, there's nobody that can match what it was like in 1994. So there is no state where less than 20% of the population is obese. So what's going on? In that same year, 1994, there's a discovery made of a gene called leptin. So this big mouse that you see here had been around since the 1950s, and they knew that something in the blood was missing in this mouse, and that contributed to its weight gain, but they didn't know what. And Jeff Friedman at Rockefeller University in New York City cloned and discovered this gene and found that its protein product is a hormone called leptin, and if you give this big mouse a shot of leptin, it turns into the normal size mouse. And everybody got really excited about that for good reason. And they came up with a model of how this is supposed to work, and this is called the adipostat. You can think about it like a thermostat for your fat. So the fat tissue in your body is the thing making the hormones. So if you have high concentrations of fat in your body, then high concentrations of leptin are now circulating in your blood. That will bind to a receptor in your brain, and when it binds to that receptor in your brain, it turns on biochemical pathways at the same time, causes your metabolism to go up and your appetite to go down. So now you're burning more and you're eating less, and that will cause you to burn through your fat reserves. So now you have less fat on your body, less going into your blood. Eventually that'll come off that receptor, and the opposite things happen. So now your metabolism is reduced and your appetite goes up. And so this is thought to keep your body weight relatively constant over the course of a year. And it's actually really good at that. So if you think about how many calories you take over 365 days, if you're just a little bit off in terms of calories that you are wasting, calories you're spending, okay? What your body is trying to do is match the calories coming in to the calories going out. If you're just a little bit off in that calculation, it makes a big difference. So what do I mean? If you eat just 4 ounces of juice, more than you need in a day, so that's like this much in a juice glass, at the end of a year, that's 10 pounds. So most of us are not gaining 10 pounds every year. I've done it before, but I don't do it every year. And so this system actually works really well. So what's happening in obesity? Well, the initial thought was, we'll just give people who are obese injections of leptin, and that will cause them to lose weight like it did for the obese mice. But that didn't work. Did multiple clinical trials, and obese humans not making leptin is super rare. It's basically been found in one family from Pakistan. But what is not rare is obesity in humans. And in humans that are obese, they're making plenty of leptin. And seems to be the problem is they're not listening to the leptin. So the brain is not listening to it or is leptin resistant. What do I mean by that? So sports analogy, sorry for that. If we think of leptin as baseball and we think of the receptor as a something in your brain like a catcher in the outfield. When that catcher catches the ball, that's when you turn on the pathways that cause you to eat less and burn more. In a normal weight person under normal signaling, there's plenty of catchers out there in the outfield, and it's very unlikely that one of those leptin balls is going to make it past the outfield. Somebody's going to catch it, and you'll get that pathway activated. But in obesity, what seems to be the situation is there's now lots of balls going out into the outfield, but there's fewer fielders. So you are very insensitive to leptin, and it's very likely that some of that signal is going to get past those receptors, and you're not going to respond to it as you normally would. This is called leptin resistance. So one thing I want to disavow from, if you hold this idea, is the idea that obesity is somehow a disease of willpower. It is definitely not. And most of this work has been done by Michael Rosenbaum, also at Rockefeller University. And over the last decades, since leptin's discovery, he's done a lot of the important studies that are done in humans for leptin. And what he's learned is that between 75 and 85% of people who lose weight, a significant amount of weight, will gain it back within 2 years. And for those few that are able to maintain that weight loss past 2 years, what they have to do is they have to eat less than they used to eat at that weight. So that sounds counterintuitive, but it's true. So I weigh 148 pounds. After losing weight, if I arrive at 148 pounds, if I am put next to a person who also weighs 148 pounds, but they never gained weight and they never lost weight, they can eat more than I can eat to maintain 148 pounds. I have become more efficient with my calories as a result of gaining and losing that weight. So if I want to maintain my weight loss, I have to eat less than somebody else who weighs exactly what I weigh, which is not really fair. Anybody who's ever been on a diet knows that you're hungrier when you lose weight. You've lost weight, you're hungrier. But what you might not know is that you perceive food differently than someone who hasn't lost weight. So they've done these functional MRI studies where they put somebody in a magnet and then they show them pictures of food and they say, how much food is that? And they judge it as less food than it actually is. And if you give them injections of leptin, then they can correctly judge how much food that is, but not without those injections of leptin. So what's emerged is this hypothesis that as you gain weight, your brain gets used to having more leptin. More of those catcher's mitts get used to being full of leptin. And as you lose weight, your brain does not get used to having less leptin. It expects a high amount of leptin, and as far as we know, forever. So they've tracked this for 8 years and still have high leptin expectations after 8 years. It may be not true for certain populations, people about your age actually. It may not be true for, but for people my age, it seems like you can ratchet your leptin expectation up but never back down again. And some of the clinical trials that are happening right now are giving people who have lost a significant amount of weight leptin supplements so that they can maintain the weight. Not so that they lose it in the first place, but just so they can maintain it. Okay. So leptin does lots and lots of things. 50,000 papers on leptins. One of the things that it does is it affects how bones grow in a way that we don't really understand. There's about 100 papers that say if you give leptin to a mouse, their bones grow and they get more dense. They get longer and more dense, and about 100 papers that say the opposite, that they get less dense. So my lab just got funded by the National Institutes of Health to look at this in a non-mammal, a non-mouse. And we're looking at it in zebrafish, which are these little aquarium fish you see on the slide here. And our hypothesis is that whether or not leptin builds or destroys bone depends on how sensitive that fish is to leptin, and that's what we're going to study. So one thing that fish have are scales, most fish, not all fish. That's a fish scale, and the thing you see here, this part right here, is the pigment part of the scale. So the thing that gives the fish stripes or bright colors comes on that part of the scale, and then the rest of the scale is bone. So big advantage of studying fish is that you don't have to kill the fish. You can knock the fish out, take a couple scales off, doesn't hurt them, put them back in the tank, and then you can study that scale as a bone without having to take out the skeleton of the fish. So we can put leptin on it, we can use different mutants that are missing parts of this pathway and try to figure out this question of does leptin build or leptin destroy bone. So what I want to leave you with is the idea that obesity is another kind of pandemic. We're in a pandemic right now of respiratory virus, but obesity is another kind of a pandemic, and it is affecting most of this country, and it will be the leading cause of death once we get past this pandemic. It's even a risk factor for this pandemic right now, that you're more likely to have serious complications of COVID-19 if you're obese. So we need to pay attention to it. We've learned a whole lot about the biology of how obesity happens, but we haven't made great progress on how we think about it as a society. So your brain is working against you, trying to maintain a healthy weight. And we just need to give each other and ourselves a break about what is going on when someone is trying to lose weight, and not think that that person just doesn't have the willpower. So thanks very much, and I'll be glad to take any questions.
Thanks, Rick. So once again, if you're out in the virtual world, feel free to type something in or just unmute yourself and ask a question. But I'll start off with one. So in '94, obesity was not nearly the problem that it is now. What do you think the causes for our high obesity rate is at the moment? Is it leptin resistance? Is it related to something else? Or is leptin more response to the obesity?
So leptin is a response to the obesity for sure. There are so many other things that affect obesity that in a longer talk, and I've got slides to show you if you want. So pollution makes you more likely that you're going to be obese if you're subject to pollution, and who is not, right? If you are in poverty, you're more likely to be obese. If you had an adenovirus infection when you're a kid, you're more likely to be obese, and that's just a common cold. So there are all these, even if your grandmother, while she was pregnant, experienced either high food availability or low food availability, then you, 2 generations later, are more likely to be obese. So, how are you supposed to deal with all that, right? How are you supposed to say all that is in your control? It's just not in your control. So all you can do is do the best you can do.
Let's see if we have anybody from the audience want to ask something. So with that, I would like to thank both of our speakers. So if you are here, give each other a round of applause. If you're virtual, you can maybe unmute now and everybody clap. But thanks again for coming. Again, look for announcements for these in the future. We'll have 2 more in November. 2 more dates in November. And certainly we'll continue this next semester. So on behalf of the Williams Honors College, I'd like to thank both Rich and David for coming and spending their lunchtime with us. And I'd like to thank you too. So hope you have a great day. Have a great rest of your week. And we'll see you again. Take care. Bye.
Thanks, everybody.